Let us take, for example, the silicon atom. Silicon has 14 electrons. According to the Aufbau principle, we first fill the 1s subshell. We know that the 1s subshell only consists of one individual orbital that can hold a maximum of 2 electrons. These 2 electrons will have to be placed with opposite spins according to Pauli's exclusion principle. So one electron must be spin up and the other must be spin down. So now we remain with 12 more electrons to be filled into orbitals. If we follow the table, the next subshell to be filled would be the 2s. And we also fill it according to Pauli's exclusion principle. So far we have filled 4 electrons. So now we are left with 10 electrons to fill. If we follow the table again, then we can see that after the 2s we fill the 2p subshell. And we know that the 2p subshell consists of 3 individual orbitals. And each of these individual orbitals can hold up to 2 electrons. So the 2p subshell can hold a total of 6 electrons. Now we must place the electrons according to Hund's rule. So we fill the first 3 electrons into separate individual orbitals with the same spin. Then we can start pairing them up, and according to Pauli's exclusion principle, we have to pair them up with opposite spins. So far we have filled 10 electrons. That leaves 4 more electrons to be filled. According to the table, we have to fill the 3s subshell next. And we fill that the same way we had filled the 1s and the 2s. So far, we have filled 12 electrons, which leaves 2 more electrons to be placed into orbitals. If we consult the table, we can see that the next subshell to be filled is the 3p. And we know that the 3p subshell consists of 3 individual orbitals. So we fill the remaining 2 electrons according to Hund's rule. Therefore, we place them in separate orbitals with the same spin. So here we have the electronic configuration of silicon. It is written as 1s2. Notice that the 2 is written in superscript, followed by 2s2, 2p6, 3s2, 3p2. So now you can attempt to use the Aufbau principle to write the electronic configurations of carbon, nitrogen, oxygen, and phosphorus, and any other element you choose. This method can be used to determine the electronic configuration of almost any stable atom. There are, however, a few exceptions, and we will talk about these exceptions in lecture 1.3.4. So before you proceed to that lecture, try using the Aufbau principle to write out the electronic configurations of chromium, copper, and molybdenum.